Hi everyone, welcome to our video on a related rates problem involving cost. Now, before we get into that, we do have a procedure for solving related rates problems that we'll kind of scroll back to when needed. But it's right here. We can read it when needed. We're going to break down the problem. Step one is to draw and label a diagram when possible. Typically with cost, we don't really need that, so that's more for geometry style problems, and it's usually well known when we need it. So if you start seeing stuff like involving triangles or rectangles, then that's where we go with that. And then otherwise, we want to find an equation that relates to variables. Again, with this, it's already kind of set up. We have the equation. Okay, and then afterwards, step three is to differentiate with respect to time. So we know it's going to be time. As soon as you see how fast is something changing, like in this, so without reading it all, I'm just going to underline the per month. Per month means we want to do something with respect to time, so that means it's d something dt is what we'll be doing. Okay, so that's how we treat these word problems, and then eventually we'll plug in the knowns and solve for whatever they want. Okay, but let's scroll real quick. Okay, so this was from a previous video, and then I've deleted a lot of stuff because the ink does not hold well. Let me scroll up faster to a video that we would have done in the past, the applications of extrema. So here we have different types of word problems. Here it's when you see maximize or minimize. Okay, so maximize or minimize is optimization. Okay, so in that's a different scenario. Okay, so just make sure we know which one's which. Okay, so related rates is doing the d dt. If they said maximize or minimize, we're usually finding a derivative and setting it equal to 0. Equal to 0. Okay, so that's the two types of word problems that we see in these scenarios. So maximize or minimize is find a derivative and set it equal to 0. Often there's other stuff that needs to be done, and this is just a very, very quick explanation. But just make sure we do know which one is which. So as soon as you see something per month or something per minute, something per time unit, it's probably this scenario right here, this whole procedure. And I'm thinking, as again, a very general quick explanation is right here, d something dt is what we need, whereas this is more just find the derivative and set it equal to 0. All right, so anyway, so let's break this down. A company that produces lamps found that the cost to produce X lamps per month is given by this cost function. How fast is the cost per month changing when production is increasing at 10 lamps per month and the production level is 40 lamps? Okay, so our first step is, we already have the equation, so kind of step one and step two are already taken care of. We're really instantly in step three in this problem. So we have our cost function is c equals 0.1 x squared plus 5x plus 100. And so what I want to do is, because I see the per month multiple times in this problem, is to take the derivative now. Let's differentiate it with respect to time. So the derivative of the cost would be dc dt, so the derivative of cost with respect to time is equal to, all right, power rule tells me that this is 0.2x, and again, attach dx dt to it. So we're doing it with respect to time. Again, special cases. And then plus 5 dx dt for the second one. And then the derivative of 100 would be 0. Okay, so this is our cost function derivative with respect to time. Okay, so we did step 3. Now step 4, we want to plug in what we have. Okay, so step 4 means, let's see what they told us. So I didn't write them to the side yet. I just kind of underlined things. Okay, so this, they're saying the production is increasing at 10 lamps per month. So the per month tells you it's a derivative. So the way that we will write this, since x is lamps, we'll say the production is increasing, meaning dx dt. So it's increasing at 10 lamps per month. So that's what this whole statement is translated into our calculus. So this is the change in the lamps, change in x per time. X over t is the change in lamps per the months. So, and then they say it's 10. They just give up the straight up number. So that means that's where I can start to plug those in. Okay, and then they also tell us the production level is 40 lamps. So they're saying X is exactly 40. And that means I could plug that into that X right there. And so our step 4, we want to plug these in after we take the derivative. Don't plug in X equals 40 into that. Don't do that. Okay, so let me underline the blue to make sure we know. Don't do that. Okay, so don't do it in this function. Do it into the derivative. So we plug it in after we take the derivative. So now step 4, let's plug in those variables. Plug in. And so we'll have dc dt is equal to 0.2 x, which is 40. So I marked it in blue. 40 times dx dt, which I've marked in red, is 10. Plus 5. Dx dt is 10 still, so 5 times 10. And then let's keep simplifying. So now we've got dc dt is equal to, okay, so this all is 80 plus 50. It would be 130. Okay, so we have 80 plus 50 is 130, and that is our answer. But let's make sure we understand what it represents. So it's saying how fast is the cost per month changing when production is increasing? Okay, so because this is positive, and notice, let's make a note. This is, when it says increasing, we know this should stay positive. Okay, so this dx dt should be positive. If it said decreasing, we would make it negative. Okay, so increasing means this is positive. Decreasing means the rate is negative. And it's marked here. I just didn't read it, so it's up above. Okay, so that is a positive 10. So this is positive as well. So that means something is increasing. And so what we're going to do to write this as, we're going to say the change in cost. Okay, so the change in cost is this, we're assuming this is a dollar amount. Does it say? It doesn't really say anything about the dollar, so let's assume it's dollars. So the change in cost is $130 per the time unit, so per month. Oh, oops, I forgot one word, sorry. So the change in cost is increasing. So because it's positive, so let's put that here too. So it's positive, so that means the rate is increasing. Okay, so let's fix that. Okay, so the change in cost is increasing at $130 per month. And that's it. I guess you could add when x equals 10 and this dx dt is 10, but let's just say it like this. This is fine. The change in cost is increasing $130 per month. Okay, so that's it. That's how we interpret it. Okay, so when it's an equation, it's usually not too bad, but we still need to make sure we know what these numbers mean in these scenarios. All right, so let's put a pause. We'll do a different scenario in a different video. If you have questions, let me know. Otherwise, thanks for watching, and I'll see you again soon.